Good day to you all. So, today we are going to talk about process packages. In fact, we are coming towards the end of the course. Beyond this, you will have the design of a complete plant to be covered in very brief. And before that, let's have an idea what a complete process package looks like and what all components it should have. To start with, let us know a few things. The process package document comes from the technology vendor. That means it is created by the vendor of technology. Suppose as a designer you are giving your design to someone else, you are the vendor. So, quite naturally, if you are talking about any project document, it must start with an introduction and background of the project. That is the first thing that is required. Now, if it is not too small a plant, even if it is, the manufacturing process of the plant and its details are detailed in this. So, these two are basically something like preamble, which will always be at the right beginning of your process package. You definitely have to provide the details of the process that is being designed and will be implemented by your client. The fundamental thing in any process is basically the balances of material and energy. So, you will have the material balance mostly in the form of a process flow diagram with its streams marked on it. The stream details will be naturally the flow rates and compositions. So, if you look at the PFT with the flow rates and composition of the streams marked on it, you will understand what exactly is the flow between the different process units, different equipment, and what exactly is the energy transfer involved in the entire process itself. You definitely can have an idea that what is the amount of energy which is required for your process, which is a very important parameter for your client to know, because he is the one, while he operates his plant, has to get and arrange for it. Next comes the gross idea about the equipment that are designed. And in order to give the idea right at the beginning, the key dimensions and the specifications are to be provided in the process package. Do not think that the process package which is given right at the beginning, it is basically the process technology package, is not the complete document with which the plant can be fabricated or can be built based on it itself. This is a starting document for making the detailed design. Normally, with the technology that is provided to the client, you are supposed to suggest a plot plan also. This could be a generalized plot plan for similar plants, or in case you have the details about the location of the plant, you may include a specific plot plan for this specific client also. Normally, the economics of the plant is also decided along with the project evaluation in the process design. That is basically the technical process package. After all, it is a document. Normally, these documents are standardized by the vendor. In India, typically the good vendors and the famous vendors are Engineers India Limited. You have a company called Technip. There is a unit called PND. Then you have got Mecon. All these companies, they have standardized these packages. Now, it is obvious the content which I have mentioned is present in this particular standardized document of the vendor, but in slightly different forms depending on the type of industry they serve. This format could be containing the specifics applicable to a particular project. It will definitely have a generalized section to standardize the engineering procedures and the practices and the inspection that has to be followed if such a plant has to be built. In some cases, you also have an approved vendor list for the specialized equipment. I will give you an example. Messrs. Universal Oil Product or UOP is a very famous company in the refining sector, and they design various plants including the fluidized bed catalytic cracker unit or the FCC unit. The FCC unit has got quite a few specialized equipment. One such equipment is the slide valve. There are few vendors in the world or few manufacturers in the world who make this slide valve. So, quite naturally, in the process package for the FCC unit which is given by UOP, the prospective vendors who can supply you the slide valve is also mentioned. The basic design and the features of the slide valves to be used in this particular plant is also mentioned therein. I have already said that the basis of detailed engineering of the plant is the process package. That means, now what I am saying is a new term which is the detailed engineering of the plant. Detailed engineering means it is basically after this stage the equipment will be fabricated, delivered, erected, commissioned, operated and maintained. So, that would be the life cycle of your plant to start with. So, detailed engineering of the plant starts with a process package which is given by the technology vendor. Quite naturally, the detailed engineering, if you are talking of, it must be having the sufficient information to start with the project description. Then if it is a big plant, block flow diagrams, and all these we have discussed right at the beginning when we talked about various documents involved in design. You will have the process flow diagram naturally with the stream flows and the compositions as well as the energy flow requirements over there, a process description of the different units which are involved in your plant, and you will certainly have the process and instrumentation diagram which will tell you what are the control loops and what are the process parameter indication loops. That means, again in industrial parlance, you can look at it and find out what are the open loops and the closed loops involved in your plant. The communication has to be in terms of drawings as well. The first thing that you have are the general arrangement drawings. That means, if it is a distillation column, what you will have is a gross dimension marked on a elevation drawing, a little bit details about the location of the nozzles, possibly the elevations at which the trays will be fixed, that will also be there, the height of the skirt support will also be there, and naturally whatever is required to have a general idea will be there. Mind it, GA drawings are not fabricational drawings. In fact, GA drawings are used in order to assemble things after they have been fabricated. Fabrication drawings are prepared separately. Now, there may be requirement for communicating additional information through additional drawings depending on the complexity of the process and what exactly is to be communicated. Normally, the instructions for layout, erection, equipment installation and operational safety is also to be covered, and it also includes the standards and the codes to be followed. In fact, if you are talking about the Indian scenario, depending on the industry, certain sections will definitely be Indian, but in case you are getting a technology from outside, a foreign technology comes in, they will be specifying certain standards according to their country or their own requirement. Either the equivalent thing has to be given in BIS or directly something like ASME or something which is more accepted, which is quite accepted internationally will be used. The standards and the codes part is extremely important. It is because if I buy particularly different specialized equipment from different countries or different manufacturers, they have to conform to the same standard in order they can be connected. That means the standards will specify not only the mechanical integrity, but it will also specify compatibility with respect to material, with respect to physical connections also. Now, the project specifications we have already said, and these are the ones. When I say detailed engineering design, the detailed engineering design would include fundamentally the design of the main process certainly. It will also include the checking of the utility and the off-site facilities. If you are getting a technology from somewhere, it has to be in synchronization with the other facilities which may be either existing or which will be added later on. One such thing is the set of utility and its requirement and the off-site facilities. Typically, I will put it like this: if you are having a particular technology which asks for a water supply at a temperature of 25 degrees centigrade, and you do not have an utility which supplies cooling water at 25 degrees centigrade, either that utility has to be managed and has to be provided, or the design has to be modified in some way. So, quite naturally, for detailed engineering design procedures, you require a sufficient information of what may be available as utility as well as in off-site facilities. Next comes in your detailed engineering the plant hydraulics. This is something which we have talked about. That means, in detailed engineering stage, you finalize the pumps and compressors, their specifications and their drivers. The equipment rating with respect to pressure and temperature are also finalized. The final plot plan is covered in your detailed engineering document. Now, you have to provide safety against expansion of the piping and equipment. This is something very important in process plants, because your installation temperature could be the ambient, but its operating temperature could be much higher or much lower in cryogenic plants, which definitely requires that there has to be provisions for either expansion or contraction of these equipment, which may require certain overpressure release, sometimes space, sometimes anchoring and things like that. Overpressure due to expansion of any trapped liquid is taken care of by thermal safety valve. This is something which we have talked about when we talked about heat exchangers. I will just give you an example. I have here a shell and tube exchanger, and what I have here are two gate valves which are isolation valves. Now, the shell side possibly is the hot fluid. This is the hot fluid, and this is, say, cooling water coming in, and a hot fluid gets cooled here and leaves here. You have isolation valves here as well. Now, what happens is, if this is shut, that means there is no cooling water flow, and you by some wrong operation you start your hot stream first. What is going to happen? The liquid between this point and this point, that is going to expand. Immediately what you will find, that the gasket which is there in the flange here, they will start leaking, because that is usually the weakest point in your piping system. So that this, if your gasket failure does not happen, if it happens, you are saved, you have saved your equipment, and if it does not happen, then possibly you are going to have tube failures. So, what is done is, you provide here a pressure safety valve across one of these valves, so that the overpressure here gets released downstream. Now, this is a pressure safety valve, no doubt, but it protects against the overpressure under thermal expansion. So, this is called a thermal safety valve or a TSV. So, this is what is meant by this. You will also notice the next item. The foundation design is finalized in the detailed engineering design stage, and the minimum load that has to be carried by the foundation is a complete water fill load in the equipment. For example, if you are talking about a distillation column, which normally will be having a lot of vapor inside and some amount of liquid, the foundation load is designed not only on the weight of the metal and the weight of the liquid which it is supposed to carry even under emergencies. It is considered with fully filled with water. This is something very often, and perhaps many do not I will say appreciate it, because it increases the foundation load bearing requirement often to quite a few times. Particularly for hydrocarbon columns, you should not consider the hydrocarbon filling up the entire column, because hydrocarbons have density less than water, and what happens is during initial stages immediately after your erection, the entire column is filled up with water and water washed. So, in any case, at least once in its lifetime it will be filled with water, and it must have the mechanical integrity to withstand that. So, note one thing, the foundation design is based on the minimum complete water fill. Now comes the consideration for the safety, which relates to the relief discharge destinations. The relief is against overpressure, and here when I am talking about the destination, it has to be a safe disposal. In some cases, if it is a benign discharge, maybe a little bit of steam and all, it could be discharged to the environment or the ambient, but it has to be located such that it does not pose any threat to the working personnel around. If it is a hydrocarbon or if it is a toxic vapor, it has to be discharged to a flare header. You definitely have to check that any such discharge is discharged safely. Sometimes safeties are also discharged into drains. For example, the pump discharge safety will be discharging either to its suction or it will be drained if it is a benign liquid like water. It is very important to note the capacity of the discharge system which receives the supply during the discharge itself. Another thing, the discharge is against a back pressure. So, if your back pressure goes up, the safety overpressure under which the safety valve operates will also go up, and this may be a threat to your equipment. So, you have to ensure such a design of your relief discharge destination which will have a fairly constant back pressure, and if it is not, you have to use special type of relief discharge valves. A safety analysis is always essential during detailed engineering design. So, these are the points which are to be taken care of in detailed engineering design, and during this design the information which has been made available to you from the technical process package is essential. In fact, that is the starting basis for your detailed engineering. I have a plant example here. It is a plant which is of hydrodesulfurization. Hydrodesulfurization means using hydrogen, you are removing the sulfur which is present in the hydrocarbon, which is the vacuum gas oil here. Typically, the vacuum gas oil will be having about 1%, around 1% by weight of sulfur, and it has to be brought down to an acceptable level so that it can be used as a component of diesel. Let us look at the plant. Here you have a hydrodesulfurizer reactor. The bottom material comes out, and quite naturally what you have here is it is preheated to a temperature of 390 degrees centigrade. You have preheat exchangers followed by a furnace. You have the makeup and recycled gas hydrogen mixed with the feed. It's a solid catalyzed gas liquid reaction. Now, what you have here is something like this. Beyond that, you cool it from 405 to a lower temperature. Beyond that, you have a plate type exchanger. Then it goes to a high pressure separator. The pressure is pretty high. In the high pressure separating drum, it flashes. The hydrogen which is unutilized and a little amount of lighter hydrocarbon which has formed comes out, it goes out, it condenses here in the two heat exchangers, and then what happens is it comes to another separator. The sulfur which gets removed forms hydrogen sulfide, and finally it goes here for recovery of H2S from that off gas. The liquid is always coming from the bottom of these. So, this is also a bottom arrangement, and it goes to a low pressure separator drum, which is again a flash. Here the flashing happens at 20 kg, whereas the upper drum or the high pressure drum, it happens at 109 kg pressure. Here again some more amount of vapor which is from the low pressure separator comes out, and here we have the vapor which is finally going to the stripper, and your bottom product here is finally to be stripped and it goes to another section after preheating. It is basically going to a stripper which is nothing but a column, and naturally in order to facilitate stripping you add heat, that means you preheat it. Now, the scope of work, if you look at, the work performed is limited to the preparation of BEDP with technology of the licensor. In fact, this is a correct, this is an existing plant, and I am not going to give you the details of this, I cannot in fact. The plant consists of the diesel hydrotreating reaction section, which is basically the reactor I talked about. Then you have the reactor effluent stripper, the fractionation system which we have not included, and a light and recovery section. The document is pretty large. In fact, it consists of first the process information and drawings to define the unit. It is something like a preamble. Then it details the equipment specification. Again, these are gross specifications. The gross drawings of showing the dimensions, standard specifications for the equipment, if any, the individual PNIDs, the material recommendations, and the related engineering design information. It does give the instrument index and the instrument data sheets. It is the same diagram which is here, and we can identify very well this is your reactor section and these are your separator section, and we do not have the fractionator here shown. The design basis, if you look at, it is VGO feedstock, it is kiloton per annum KTA. There are two vacuum gas oil streams which is coming from vacuum unit 1 and vacuum unit 2, and also you have a stream which comes from coker, which is the heavy coker gas oil. The total capacity is 2000 kilotons per annum. The overall conversion is 40%. So, all these are the general information about the plant, and your hydrotreated product is supposed to contain not more than 500 ppm of sulfur in the treated vacuum gas oil. The major products are naturally the hydrotreated VGO and the diesel, and the lighter products are these three. You also have other streams which we should not call exactly byproducts, it depends on the vendor how they call it. You have sour water, that means water which is contaminated with H2S. You have a small quantity of slop oil, which is a waste oil which is reprocessed later on in other sections of the refinery, and you have a recycled gas bleed which goes through the flare. You will notice one thing. This is particularly true in case of catalytic processes. The yields, rather the activity of the catalyst at the start of run and the end of run, the start of run and the end of run will be different. So, the product yields are always to be specified under these two conditions, both at start of run and at end of run. The product properties are also to be specified, but more or less it really does not matter, because you have to meet the product properties. That is a requirement. The init material of construction has to be specified. You have seen that there are amine, you have injection water in the various equipment in the PFD which has been shown to you. In fact, it is not exactly a PFD, it is basically a P&ID, part of it at least, and these also have to be specified. You have definitely to be satisfied with the battery limit conditions. I had defined what exactly is battery limit earlier, but I just repeat it, saying it is basically the boundary within which the physical plant lies. Whatever crosses the boundary has to be specified quite naturally, and in fact, it is this battery limit boundary which defines your plot plan. In plot plan, when you say you may have to provide some other additional information, for example, about the wind direction, because that is related to safety, because if this be the wind direction, you will prefer to have your furnace here downstream of the wind. You should not have the furnace upstream of the wind, because in that case you are subjecting your entire space downstream within your battery limit to chance of fire. The chemical requirement naturally is another important point. The process information normally is, again I have repeated here, it will be specified in terms of different sections of the unit, and quite often in case of a plant like this, you require separate process flow diagrams which are numbered, and this PFDs may be different for start of run case and end of run case. Why? The reason is very simple. The reason is during start of run and end of run, your catalytic activities are different, so will be your yields. You may be having the same amount of same product quality, but their yields possibly will be different. So, you have sections which will be detailed this way. You definitely have a description in the language. For example, these normally, at least in this particular process package, there was a description of the feed section. Normally, the feed section will also include the offsite pumps, which is a typical system. Reaction section here. All other sections like stripping, fractionators will also be outlined separately, including the process flow diagrams, stream data, process control strategy as PIDs and interlogs, and the utility summary. The equipment normally will be specified in terms of, or rather by using certain forms which are standardized by the vendor. The reactor, the vessel, column, heat exchanger, all are specified in terms of data sheet. So, these are standard data sheets which are to be filled with respect to individual equipment, and it must be specified very, very clearly along with the standard drawings and specifications. I think this gives you an idea that what you can expect in a complete process package which comes from a vendor, and what to look for if you get one in your hand. With this, I stop here today. Thank you.